One of our, oh, perfect, got it.
Okay.
One of our students is going to be working on a systematic review. So happy last day of June, ready for July, I hope everyone is. So I want to introduce our speaker today, who's Dr. David Garcia. He is a graduate of the NYU Meyers program, just completed his dissertation and defended it a couple of months ago. We're so pleased and proud of him as our newest graduate. And he's going to talk to you about systematic reviews. He's currently in a postdoc at NYU with Dr. Ann Margaret Navarra, doing work in HIV research, and really has a compelling program of research, and I think is one of our exemplars in systematic reviews. So Dr. Garcia, and I love calling you Dr. Garcia, take it away.
Okay. Hi, good morning, everybody. So today I'll be going over 10 steps for conducting a systematic review. So it's really nice we get to do this from the comfort of our own home. I am also recording this so you can go back to it, and I'll share these slides with Erin Pace so she can send them out to everybody so you can refer to them. I also have all of the links and references in the notes so you can refer back to those. So can everyone see my slides? Everything's good?
Yes.
Yes.
Okay,
Yes.
Great. All right. So if at any point there's any question, feel free to just unmute yourself. You don't have to raise your hand or anything because I have two screens, so I probably won't see the little icon. So let's go ahead and get started here. So let me put on the little spotlight. There we go. So here we go. So we'll start with the objectives here. So we'll go over the different types of evidence today. We'll go over the definition of a systematic review. We'll go over some key terms, and then we'll go into guidelines for writing your systematic reviews. We'll go into writing a protocol, and then we'll just summarize with 10 steps for conducting a systematic review. So not all evidence is created equally. What you see here is a hierarchy of the different kinds of evidence, where at the bottom you have your opinion pieces from experts and authorities or committee reports, organizations, and these are not based on research usually. Then above that, you have qualitative studies. And then when you do a review of multiple qualitative studies, that's called a meta-synthesis. And then above that, you have your non-experimental studies, and those are like studies conducted with surveys, which is like what I used for my dissertation. And then you have quasi-experimental studies. So it's experimental, but there's no control arm to compare it against. And then above that, you have the randomized control trials, where you do have a control arm and your experimental arm. And then when you have multiple studies such as these, you can conduct your systematic review or meta-analysis. So that's just kind of a rundown of the different types of evidence. And then there's a citation in the notes of these slides where you can refer to this hierarchy in depth. So next, let's see if we can watch this little video. You know what? Let me make sure we can all hear it. So real quick. Screen share sound. There's a little checkbox you have to click. There we go. All righty. See if we can hear this. So this is from Cochrane.
What are systematic reviews? Systematic reviews help make sense of many kinds of data. They're a way of reviewing all the data and results from research about a particular question in a standardized, systematic way. A systematic review helps give an objective and transparent overview of all evidence surrounding a particular question. The Cochrane collaboration logo visually represents how results from some systematic reviews can be explained. Here's how a systematic review works. First, a question must be defined, and an objective method for asking the question is agreed. Imagine a circle as the area defined by a question. Everything inside it concerns the question. Everything outside of it does not. In this circle, relevant data will be included. A search for relevant data begins. This data can come from many sources, including data from clinical trials. Imagine the shapes represent data sets from different research, for example, different clinical trials. The data set must be the right shape to fit. Only data from research that matches certain criteria can be included so that the results are reliable. For example, selecting research that is good quality and answers the defined question. If the research meets the criteria, more detailed information about the research can be collected or extracted. Information extracted can include how the research was done, often called the method, who participated in the research, including how many people, how it was paid for example, funding sources, what happened, the outcomes. This information is judged against criteria in order to assess the quality of the research. Once the information is extracted, it can be combined using complex statistical methods to give an overall result from all of the data. This circle is one way of representing this data visually. It's called a blobogram or a forest plot. The area of inquiry, defined by the question, can be divided into a yes and a no half, a positive and a negative side. The shorter the line, the more confident we are of what the data is telling us. Think of a longer line as less focused and scattered data, and shorter as more focused and bunched. Imagine knowledge as light and ignorance as darkness. The more spread the focus of the light, the weaker it is, and the less clear things are. If the light is focused and data is grouped more clearly, we can be more confident of what we see. The diamond represents the combined results of all the data included. Because this combined result uses data from more sources than just one data set, it's considered more reliable and better evidence. The more data there is, the more confident we can be.
Okay, was everybody able to see the video?
Yes.
Okay, good. Alrighty. So they don't really define it exactly. So I developed a few more slides here. So a systematic review is basically a review that uses explicit systematic methods to collate and synthesize findings of studies that address a clearly formulated question. So that's really the key there, is that clearly formulated question. It's also a type of review that synthesizes the state of knowledge in a field. It identifies problems in primary research that need to be addressed in future studies, setting future research priorities. It also generates or evaluates theories about how or why phenomena occur, and it addresses questions that otherwise cannot be answered by individual studies. The knowledge it generates are for various audiences, such as patients, healthcare providers, researchers, or policymakers. So before you get started, these might sound pretty basic, but it's important that you kind of hash out what these different terms are. So a study is basically an investigation, such as a clinical trial, that includes a defined group of participants and one or more interventions and outcomes. A report is a paper or electronic document that provides information about a particular study. So these can be journal articles, preprints, abstracts, clinical studies, dissertations, unpublished manuscripts, and so on. Actually, many studies have multiple reports, such as the protocol, which is the roadmap or the recipe for the study. And then you have your results paper, which is your outcomes. And then sometimes when you're conducting a study, you have secondary outcomes, and you can develop those into another paper as well. So an outcome, yeah, go ahead.
Let me ask a question about the reports.
Mm-hmm.
So are reports or are systematic reviews one type of report? Or is that not like the correct way to think about that?
So the report is really about a study. So this, so this branches off. So you have your study. So let's talk about like maybe the IPREC study, which was for PrEP. So that was one study, but there were many reports that came out of it. So a systematic review would take all of those reports. So it's not a systematic review. I wouldn't consider it as a report. It's more of a synthesis of the many different types of reports. Okay.
All right, thank you.
Okay.
That helps.
So for your outcome, an outcome is an event or measurement collected from participants in a study. Did I read that right? It's an outcome or measurement collected from participants in a study, such as quality of life or mortality. And then you have your results, which are a combination of point estimates, such as mean difference, risk ratio, or proportions. And then you have your precision estimate, which is like your confidence interval for each particular outcome. And then when you have a meta-analysis, that's a statistical technique for synthesizing all of those results. So just like the previous question, when you have multiple reports in your systematic review, you're going to synthesize all of those numbers and crunch out one number that kind of takes a synthesis or an average of all of that data. So it's in the title of systematic reviews. It's systematic. So there's guidelines that are designed to improve the reporting of systematic reviews. And that's the preferred reporting items for systematic reviews and meta-analyses, which is abbreviated as PRISMA. So when you see PRISMA in your readings, this is what they're referring to. And this was updated in 2020. So we'll go into what those changes involved. But really, the PRISMA statement really identifies how you're going to identify your studies, how you're going to select them, how you're going to do your critical appraisal, and then how you're going to synthesize the knowledge. So it's a 27-item checklist with recommendations for each item. And then it also has information on how to construct your flow diagram. It aims to benefit your authors, editors, peer reviewers, and various users of systematic reviews, such as the people who develop guidelines, policies, healthcare providers, patients, and other stakeholders. So this is what the PRISMA checklist looks like, right? It's really no big deal. And it just spells it out for you. So it even tells you how you want to identify your study or your paper as a systematic review. There's also a PRISMA for the abstract, detailing how you want to write out your abstract. And then it goes into all the different parts that you'll need to address in your paper, such as the introduction, the methods, the results, and so on. So this is just a snapshot really of the first page, but I have the link in the notes here, and you can see it's pretty lengthy, and that's for a good reason, because they really want to make sure that you include everything that's necessary. All right, so this is the PRISMA flow diagram. It might look different than what you're used to seeing, but this is the new 2020 version. So it involves all of the same things. It's just kind of more streamlined now. So it talks about how many records you identified from your databases, which databases you used, how you removed your duplicates, which were ineligible, and then the records removed for other reasons. And then you go on to how many you screened, how many you excluded, and so on and so forth. So there's also a link here in the notes on how to generate this. So you don't have to build this like, with Microsoft Paint or anything. It's already there. You just have to plug in all of your different databases and numbers. But if you're using software such as Covidence, which we'll talk about later, it does it for you. So that's really good. So it'll keep track of it, and then you can just kind of import those numbers yourself and manually create your PRISMA diagram. So before you get started, it's really important that you have a clear plan, and that involves writing a protocol. So a protocol is an a priori plan that will guide the systematic review process. The sections include your background of literature And it's really important that you look at what systematic reviews have already been published. You don't want to reinvent the wheel, but you can see what's been done and then maybe take it a step further. So maybe you want to look at specific populations, such as people of color, or maybe you want to look at specific regions, such as the South, stuff that has been traditionally underserved in research. So next you have your review question, then you have your inclusion and exclusion criteria for your studies, and then you want to identify the types of studies, the populations, the interventions, exposures, and outcome measures. Then you'll have your search strategy. So what databases will you go into? Then you'll have your study selection methods, the critical appraisal process, which we'll talk about briefly, and then how you'll extract your data and synthesize the knowledge, and then the time frame for conducting the review. So once again, Prisma has a checklist for this, how to write your protocol, and that's given here in the link below. So where to begin? So we've kind of gone into a lot here, and you might have seen this graphic from the library. So first you'll formulate your research question here, and then you'll develop your literature search, and then you'll ID your studies and select those studies from the databases. Then you'll do your critical appraisal and data extraction, synthesize that knowledge, and then disseminate the findings. So you could follow the little roadmap here specifically. That way, when you're actually writing your paper, that way you don't skip to a different section and then have to go back, because that'll kind of muddy the water. So you do want to be systematic when you're writing your systematic review. So step one, you want to develop your focused research question. And I was talking with Dr. Dixon before this presentation, and many of you are already working with your mentors. So this is, if you haven't developed your research question, this is how you'll go about it. So you'll follow the PICO format, where P is your population, your problem, or your patient, and then I is your intervention, C is your comparison, O is your outcome, and T is the time frame or type of study, and that's optional. So it's important that you really iron out what population or problem first, and then as well as the intervention. And then later on, you can go over the comparison to kind of narrow down the literature if necessary. So for the problem, population or patient, you want to consider what problem needs to be addressed here. What characteristics describe the patient population or disease of concern? And this is often considered your dependent variable. So next is the intervention. So what treatment or exposure is of importance here? How does this affect the patient, the problem, or the population? This is often considered your deep independent variable. So for your comparison, what alternatives are there to the intervention? Is there a different intervention? Is there a standard of care? Is there no intervention at all? And this is your control group. For your outcome, what are some important effects that are relevant? What can be measured to show the intervention accomplished or improved something? And then for your time frame or type of study, is there a time frame that the intervention should achieve the outcome? What types of studies could best be used to address the question? This is optional, but it can help narrow that search. So this is a summary. So when you're writing your question, you can go back to this slide, and you can see here you have different types of questions, right? You have your intervention or therapy questions, your etiology questions, diagnosis or diagnostic test questions, prognosis or prediction questions, or meaning questions. So you can certainly fit in each of your components here into the little template. That way you can write out your question and refer back to it, because it's really important that you continue to do that as you develop your systematic review. So now we'll have a little bit of interaction with the audience. So this is an abstract I pulled from the literature. So it's entitled Positive Emotions and Cardiovascular Risk Reduction in Diverse Young Adults, a systematic review by Alexis Wasserman, a BSN student from NYU, Rory Meyers College of Nursing. So if I could have, let's see, I'll just call on one person. Teresa, are you able to unmute?
Yes.
Okay, so if you could read us the background and purpose.
Sure. So, diverse young adults are at an increased risk of developing cardiovascular disease. Early engagement in preventative behaviors can improve health and well being, lowering CVD risk in later life. A relationship exists between positive emotions and engagement in health related behaviors, yet there is limited research on the association of positive emotions and CVD risk reduction. The purpose of this systematic review was to examine the association between positive emotions and CVD risk reduction in diverse young adults.
Awesome, good work. So if you could call on one other person to identify what the problem or population
Okay.
was.
I'm just going to do the first person I see. So, Natasha.
The population is young adults.
Yes, young adults, specifically what kind of young adults?
Diverse young adults.
Yeah, diverse young adults, And then Natasha, do you want to call on somebody to identify the intervention?
I'll just see the first person I see, which is Adrian.
Okay. Adrian, are you there?
Oh yeah, I was just on mute.
Okay.
So the intervention is about the association, or I guess preventative behaviors, and improving well-being in that relation to cardiovascular risk reduction.
So, okay, so can you repeat that one more time, Adrian?
Sure. So is the intervention about doing preventative behaviors to associate positive emotions to cardiovascular risk reduction?
Yes, so it really, yes, so the exposure here sounds like it's the positive emotions, right? And so the outcome is, I think you're blending them there. So if the intervention is positive emotions, then the outcome must be
Oh, the risk reduction in
the CVD risk reduction. Exactly. Okay. And then do you want to call on somebody next?
Sure. I'll call on Brianna.
Okay, Brianna, can you unmute?
Hi.
Hi. So do we know, let's see, is there a comparison group so far?
Would it
And I'm
be
not trying to trick you. Yeah, go ahead.
comparison group?
Yeah.
Would it
Brianna,
be?
yeah, go ahead. I keep cutting you off.
It's okay. Would it be the part that mentions the relationship between positive emotions and engagements and CVD risk reduction, or?
I'm going to leave the question mark there. I think maybe we need to keep reading. So I don't think we have enough information just from the background. So far we have CVD risk among diverse young adults, and then we have the exposure to positive emotions, and we have CVD risk reduction. But I don't think we have the comparison. And then we don't have a time frame here. So would you like to read forward the methods?
Sure, I can do that.
Okay.
Methods. Following PRISMA guidelines, PubMed, CINAHL, and PsycInfo databases were systemically researched for randomized control or cross-sectional studies that evaluated the impact of positive emotions on the risk for CVD in diverse young adult populations. Inclusion criteria were CVD risk factors as an outcome measure, positive emotions, primary prevention of CVD risk factors, adults 18 to 29 years, and English language. No time limits were placed on the search. 2 team members assessed content and quality using the National Heart, Lung, and Blood Institute quality assessment tools.
Excellent. So I think we have more data now. So Brianna, do you want to call on somebody?
Sure. Sophia.
So I see that the types of studies is randomized control or cross-sectional studies. As for the time frame, I'm not totally sure.
Yeah, and sometimes it doesn't have to be here, but I think we see no time limits were placed on the search. So as far as time limits, they didn't say the time limit for the intervention, but they showed that there were no time limits placed on the search. So they look back as far as possible that they could. So that's good. So we see here, I think, yes, we have randomized control trials and cross-sectional studies, and then no time frame. So very good. So that's really how a PICO question comes in handy, because it helps you conduct, how to begin your study. And that's why it's so important that you have a good question. So this was actually published at the ENRS conference in 2020. All right, so very good. Thank you everybody for participating, and sorry if I put you on the spot there. So for step 2, you want to develop your literature search strategy. So you'll choose your databases that are appropriate for your research question. And I have the link here. So it's helpful if you download this Boolean worksheet from the library. And this is right from the library's website. So maybe you already went over this with the librarian, but sometimes you have to see things more than once. So you'll select your recommended databases, whether it's CINAHL, which is nursing based, and then PubMed, which is more medicine, and then PsycInfo, which is a little bit more interdisciplinary. So some people usually start with those top 3. And then, of course, if you want to search for systematic reviews, you might look in Cochrane, or if you want to look for other types, they're all there. It's not necessary that you use all of these databases, though. So next, you'll want to perform a simple keyword search for your chosen database. You can start with PubMed. That's usually where people start. Remember, this is not like Google. You can't just put in, an easy search. It's a little more methodical than that. So you'll identify keywords that describe an important concept for your research question. So for your PICO question, really your concept is your patient problem or population. And then your other concept is your intervention. So you'll take those 2 components from your question and you'll put them into the database. So it's going to have different lines there where you'll type in each of these. So here they're using the example of hospital-acquired infection and hand washing. And so when you put those into your database, you're going to use the word "and" to connect them. So you're looking for studies that are hospital-acquired infection and hand washing, because if you put "or," then you're going to get either hospital-acquired infection or studies that talk about hand washing. So you want to merge those 2, and that's why they use these 2 circles here. So then you'll want to refine your search. So you're going to expand your search by using mesh terms. So mesh terms are the actual vocabulary that's indexed in PubMed, and those are your medical subject headings. So you can go into PubMed and you click on mesh terms. So maybe cardiovascular disease is indexed as something else. Or maybe you're looking at heart attacks and maybe it's under myocardial infarction. So you really want to use the vocabulary that articles are indexed under. So from your initial search results, you'll retrieve alternate forms, which are those mesh terms, and then you'll combine these. And this is when you'll use "or." So you'll have hospital-acquired infections, or cross-infection, or nosocomial. And then for your other concept, you might have hand washing or hand hygiene or disinfection. And so what the database will do is it'll just create like a bracket or parentheses for all of these and all of these. And then you can use and again. So here you'll have all of these terms and all of these terms. And that way you'll start to really refine your search, and maybe you'll get more, or maybe you'll weed out some that weren't quite a good fit to begin with. So next, you'll want to limit your search. So just as we saw in the abstract before, you can put in your article types. Maybe you're just looking for randomized controlled trials or cross-sectional studies. Maybe you're looking for literature for the last 5 years. Maybe you want to specify English studies that were published in English, or maybe you're looking at a specific age group, such as emerging adults. And then the librarian here says that for age group, there's an actual filter for that. So maybe you don't want to put in pediatric or elderly. You might want to just select the age group. However, this is not always indexed. So just be careful. You might still have to sort through about 1,000 articles if you're looking at a specific age group, which is fine. I don't want to scare you with the number 1,000, but most likely you're going to have over 1,000 studies to go over. So next, you'll download your citations from your databases. So remember, the systematic reviews require reporting according to the PRISMA 2020 guidelines. So it's important that you use reference management software to organize those citations from each database. I work with Zotero. It's free. It's actually recommended by the library. So there's a link there on how to get it and how to use it. It's actually really easy. So just look into that. You'll export all citations, so all of them. So if you did that search on nosocomial infections and hand washing from PubMed and you got 1,600 citations, you're going to download all 1,600 from PubMed. And then maybe CINAHL gave you 800, you're going to download all 800. I'm not talking about the whole file, just the citation. And those are going to go into Zotero, and you'll put those in different buckets or folders. That way you can manage them, because remember, in your Prisma diagram, you're going to want to say use PubMed and you got 1,600, you got CINAHL, you use CINAHL and you got 800, and so on and so forth, because it's a systematic review. So next, you're going to want to analyze your citations. So all of those 1,600 and all of those 800 citations, you're now going to move them into Covidence for your data extraction and collection. This is also web-based. It's free, so don't worry. There's a link here on how to get set up. You just have to kind of invite yourself, and then you'll get an email on how to set it up. And so this process begins with 2 researchers, and you'll begin by screening your titles and abstracts. So just because you have 1,000 or 1,600 might sound like a lot, but you're just looking at titles and abstracts. So if it doesn't even talk about nosocomial infections and hand washing, it's out, okay? And that's how you just weed through all of those articles. Or maybe if you were just looking at 18 and over, or let's say 18 to 25, and it's talking about the elderly, then you can just kick that out of your search. And you'll do that in Covidence. It's really easy. It's just yes, no, yes, no. Next, you'll want to do your screening for full text, and it's the same thing. You're going to use your inclusion and exclusion criteria, but this time you're going to look more in depth. And then you're going to resolve those conflicts. So the 2 researchers, if there was a conflict, one said yes, one said no, you're going to have to resolve those conflicts. And this is what it looks like. So this is actually the older Prisma diagram. So this is probably what you're more familiar with. I still see this. So you'll see here, like CINAHL, they had 285 citations. Then they used Embase, Medline, PsycInfo, and Web of Science. And these were all the citations that they pulled from their searches, and it totaled 1,911. However, 541 were duplicates. So what's great about Covidence is it automatically recognizes all of those duplicates and it's going to get rid of them. So then it leaves you with 1,370, and that's where you apply your inclusion and exclusion criteria based on the title and abstract screening. And then from 995, they whittle them down to 375. Then you do your full text. They excluded 366. and they were left with 9. So that's basically how you do your systematic review. It's very methodical. It's a bit labor intensive considering the amount, but it's done in a group, so it's not so bad, right? Misery loves company, so there you go. So just to reiterate, we have our number of citations identified, the databases used, how you removed your duplicates, what you included and excluded based on title and abstracts, then what you included and excluded based on full text, and then the total number of studies, right? And remember, you don't have to generate this yourself. It's already here. You just go to your Prisma statement, you download the template, and you're just going to plug in those numbers. But actually, Covidence makes it for you. Except it's just not really publish ready. So you kind of want to take the numbers from Covidence and create your own flow diagram. And remember, the updated one by comparison looks more like this. So it's just kind of more modernized. So next is step 8 here. So this is your data extraction phase, where you'll develop a table of evidence to help with the synthesis and reporting of your results. So in the last example, there were 9 studies identified, right? So how are you going to look at 9 studies? It doesn't sound like a lot, but it is. So you really want to open this up in Excel. There's a template provided by the library in the link in the notes here, but you're just going to put your author, title, and journal, the year published, the purpose, the number, it looks like this is the number of participants, the subject characteristics, the sample design, the year the data was collected, the control, the intervention, a brief, synopsis of the conclusion, and then maybe any comments you have. That way you have kind of now a table where you can begin your synthesis. So we'll talk a little bit more about synthesis in the coming slides. So you're not done there. After that, you've already extracted the data, but now remember, just because something's published doesn't mean it's high quality. So after your sample has been identified, again, 2 reviewers must examine the quality of each study. So there are actually many tools out there that are validated for critical appraisal. One that we've used before is the National Heart, Lung, and Blood Institute tools here, and that's a hyperlink, so you could click that, and it'll take you to this little table here, and you just pick the different study that different types of study that you want to critically appraise. So, for example, like in the abstract before, they use cross-sectional studies. So you would just click this, and it's just another exciting checklist where you'll go and just go through the different topics and see how the study measures up. And that's it. And then you can create another table, such as the one before, just talking about the pros and cons. That way you can, again, synthesize that data. So for the synthesis, right? So you're going to summarize the characteristics and the risk of bias among your studies, right? So maybe 5 studies looked at populations that were mostly white, and maybe 1 looked at people of color. And then, so you're just going to start kind of counting all of the characteristics that emerge from your tables there. That way you can start synthesizing the data. And then you can also present the results of statistical syntheses. If you're working with a biostatistician, they can help you use specific software where you're going to pull all of the data that was generated in each of those reports in your study, and they're going to combine it into one statistical synthesis. That's if you're doing a meta-analysis. And then finally, you're going to provide an assessment of the body of evidence for each outcome examined. So what's the state of the science? Is it poor? Is it lacking diversity? So you really want to make that statement once you finally synthesize the evidence there. So everything we've talked about today is here in the references. So if you want to go more in depth into the steps, this is the article that was adapted. These slides were adapted from. And then this is this here, if you have the research book, the Haber and Lobiondo, this is where you could look closer at the hierarchy of evidence. So I think that's it. We can go over Pico questions, and then we can also answer general questions. So first, let's start with some general questions here. Were there any questions about the process?
I just have a quick question on what you consider like the time limit of the study is. Is it
Mm.
like the period of time it takes for the systematic review to be completed, or like how long the study like that we're looking at lasted for?
Yes, so it can be any of those. So if you want, so it's important that you actually always talk about the time frame, in my opinion. So let's say in your methods, you're going to want to say, if you conducted this interview between May and August, you're going to want to say, we search PubMed, CINAHL, and PsycInfo for research articles between the time frame of May 2022 to August 2022. That way it's definite, because research continues to emerge. And if somebody's, you remember, this might not get published until a year later, and they're going to say, well, hey, they omitted these 5 studies, you know, and these were also in 2022. So if you put that time frame on there, you'll know, you know, what, like, kind of telling the reader this is when those studies were searched. But also, it can also be the time frame from, like, maybe you're just looking at the last 5 years, right? So studies that were published in the last 5 years. So it's important that everything is very discrete. So those are 2 different types of timeframes. Or what came out of the literature here from this slide deck was that the time frame of the intervention. So maybe if you're looking at blood pressure readings that were measured for 5 months, right? It's kind of an arbitrary number, but maybe studies only look at blood pressure for 5 months. So you're just going to want to be very concrete for all of this as far as what timeframes were used. And that can go in your inclusion and exclusion criteria as well, because that's how you're going to weed out articles. Go ahead. I think you had a phone.
Thank you.
Okay, thank you. Any other questions?
I just want to know the difference between an integrated and a systematic review.
Yes. So good point. So integrative reviews are a little bit more broad, right? So integrative reviews can include qualitative data. They can include quantitative data. They can include RCTs, cross-sectional studies. So it's kind of a little bit of everything. So it lets everything in. They're a little bit more complicated because first you have to synthesize your qualitative data, then your quantitative, and then, you know, so if you had an RCT, it had 2 arms, right? Your control group and your experimental group, but then you had a survey study that was non-experimental. So if we go back to our hierarchy of evidence here, remember, not everything is created equally. So when you do an integrative review, you're letting all of that in. So it's a little bit more difficult to synthesize. So what it's going to boil down to is how you extract that data. You know, so if you look then at the last slide where we have our table for data extraction, you're going to want to put in all those numbers. Except when you're doing your synthesis and you're kind of saying, well, this study said this and this study said that. Well, maybe we have to take it with a grain of salt because that study was an RCT and this study was a survey. So it's a little bit more complex. The systematic review kind of levels the playing field and helps you just identify specific studies. Does that make sense, Natasha?
Yeah, it does make complete sense. Thank you so much.
Okay, thank you. Any other questions? So I don't hear any, and that's okay. If there are any, we can certainly go back to them. So I was talking with Dr. Dixon, and she wanted you to share with the group if you're working with somebody or if you're doing your own paper, if you could just share your PICO questions with the group. That way we can know what everybody's working on. So feel free to unmute and we can just have a little discussion like that. And you can turn on your cameras. I'm going to go ahead and stop the share now. There we go.